Cool. Love testing in production. Awesome. So sometimes I wonder what's the point? When you have this configuration management, when you have people, you have systems, infrastructure, everything working together, and we have one of the largest, most complex systems in the entire world just sort of breaking apart in real time. And you can't really do anything about it. You can't manage it. You can't configure it. There's no rebooting an entire government. With configuration, at least. There's no YAML that you can apply to a dictatorship. You know, it'd be interesting to see how that might work. I don't want to, but it will be interesting. And so I'm sitting here just sort of wondering, what are we going to actually do about everything? And as I was trying to write the talk, it wasn't quite coming to me as cleanly as I might have hoped. And so as I looked for the words and I looked for what to describe and how to think about it, I realized, so you have this software thing going on, we have this configuration thing going on, and we have the people. And it's really about the people. It's always been about the people. And when you think about the systems and you think about how they operate and how you manage them and how you configure them, the people are what make it work. And so as we start sort of watching the world descend into this chaos, as we kind of hit this point of wondering how we even can manage our own life and manage our own everything or do all of that, it's the people at the end of the day that are still there for you. When your computers are blowing up, when everything is not working, when you can't do anything meaningful whatsoever, you still have the people. And so that's really what this talk is going to be about. It's going to be about the people. Because that is what makes everything continue to work. Even in the face of the most ridiculous, unhinged nonsense you've ever seen in your life. So, as I'm sitting here trying to figure out how to tie everything together in that talk and try and figure out how we talk about the people, usually I have to sneak the people in. Usually I have this fun technical talk and I sneak the people in the last minute. On this one, the people have to be first. They can't be a side comment. It's the whole thing. And so that was a bit of a challenge. But one of the things that I've noticed the hard way is when you actually sit here and think about configuration management or just management in general, you don't really control it. Now, one of the weird things about management is the more you manage, the less you control. And that also happens for systems. They're adaptive, they're complex, they're chaotic, and the more you think you can manage it, the more you will find out that you are very, very wrong. And so when you think of system management, configuration management, people management, all of it, management is about the relationships. It's about understanding the people, about understanding all of that. And so as I'm sitting here thinking about this, people, the relationships, I'm realizing that I personally have about 12 hours to decide whether or not I go back to the United States ever, and whether or not I leave everything behind. And that is difficult. But we're here to talk about technology, and we're here to talk about configuration. We're here to pretend that the world is normal as it blows apart. And so, we can kind of do both. We can talk about the people, we can talk about the management, we can talk about the systems, and I'll let you know if I stick around for another 10 years, or if I go back to the United States, or if I get stuck, or who knows. Who knows? It'll be day by day. But it'll be tricky, it'll be difficult, and you have to remember that you can't control any of it. So even as we talk about the configuration management, even as we talk about all these wild aspirations of having these complex systems that are imminently controllable, imminently understandable, it's kind of a lie that we sell ourselves. At some point, the control disappears. At some point, things blow up and you can't actually piece it back together. At some point, you end up wondering, are you going to see your family ever again? Or are you ever going to see your cluster ever again? Or are you ever going to see any of this other stuff ever again? And at some point, you have to remember it's about the people. It's about the relationships that make everything work. And that, at the end of the day, keeps you going. But we are here to talk about software. So let's pretend we can talk about software right now. So software is one of those things of, what is it even? When we talk about this software management, this configuration management, these systems, what is even software? There's a lot of different definitions one might have. You can think about, I've heard a lot of different ones. I've heard a lot of different concepts and a lot of different definitions of software over my life. One of my favorite definitions is teaching sand to think. Which, is that wrong? Not necessarily, but it's also not really right, because it doesn't have people in the definition. And I find it so difficult to think about this concept of humans working together to understand and program and do this really cool thing, and somehow the definition doesn't involve people. That doesn't seem right. Another definition that I've heard quite a bit is that software is a mistake, which is also kind of not wrong. But also that definition doesn't have the people in it. And, okay, so we have these other definitions. Here's the one that I like, and I will tell you why. I like this definition of software as an explanation of how we see the world through each other's eyes. Because there's this really, really cool thing that humans do, and that is that humans communicate. Humans talk to each other, humans learn, and we have this really interesting ability to make noises with our mouth, and then those noises teleport an idea from one person's head into another person's head. And that is the most weird-ass cyberpunk superfiction thing I've ever heard of in my entire life. And the wild thing is that for a lot of you, English is not your first language. So not only am I making a bunch of noises and flapping with my mouth, but when you go home, you make an entirely different set of noises. And somehow you can still understand me. And somehow we can still communicate. And somehow we can still build this thing together. And we can still figure out how everything works. And I think that is super, super cool. Because in the end, this software thing is about learning. So as an example of taking these words, taking these noises out of our mouth, I want you to picture in your head for a moment, what if someone took this software thing and they said, I have an idea and I want to take this idea and make it reality. And the idea is, let's have this document and let's work on this document together with a whole bunch of different people all over the world, and they're all going to contribute to this document. They're all going to edit it in a whole bunch of different ways, and they're going to start building this idea in a collaborative fashion. And there is one kind of word in the English language, one sort of piece of software that most people would use to describe this. And I want you to think about it in your head. What's that word? And it's we're probably thinking of Git, right? Unless you're really cool and you're thinking of Mercurial. But you're probably thinking of Git, or maybe Dart if you're a Haskell programmer. But that concept, what's so fascinating about it is it's so complicated. It is so complicated. Distributed version control, it took us like 30 years to get anywhere close to that. We had millions of hours of human effort, hundreds of people, thousands of people collaborating on this singular idea, piecing it together bit by bit all over the world, multiple iterations of it, turning that into just a single word that I can use to teleport all the complexity of that idea into your head. And that is super cool. That is amazing. That is, to me, one of the most beautiful things of humanity, that we can do this, that we have figured it out, and that despite the fact that we tend to use this concept of ideas often for evil, we do so much good with it. We decided to build Git, we decided to build Linux, we decided to build Kubernetes and Terraform and Ansible and System Initiative, all these fun things, hundreds, thousands of companies, millions of lines of code, thousands and thousands of ideas proliferating in the world just because we could. Just because we were audacious enough to think a single word, a single concept, a single book is not sufficient to describe an idea. I'm going to take these rocks and I'm going to teach them to think, and I'm going to encode this horrifically complex idea into these rocks, and that is what I'm going to do in my spare time. What? Humans are weird. I mean, in my spare time, I do that. But I also do a lot of other things. But we love each other. We love sharing cool, neat, wonderful things with each other. That's what gets us going. That's what keeps us going. And that's, to me, beautiful. And so we also have configuration. And configuration is one of those things that is kind of like software, but kind of not. And we have a lot of different definitions of it. Here are some of the ones that I've heard over time. I've heard the configuration is typo-driven development. Pretty much nothing in this world gets people going quite like sitting there, watching your CI system go, typing up this file, hitting the button, getting the coffee. Oh, it reminds you of the good old days of dial-up and floppy disks. Back when they were floppy, just like put that in there, just hit it, you got your coffee, like, well, we're back in the glory days. We're back in the glory days. And then it's like, oh, missing indentation, line 5. It's actually on line 12, but you'll never know. Like, is configuration typo-driven development? Well, I like the definition because it's funny, but it doesn't have people in it. So I don't know if it really fits for me. Another definition that I've heard is configuration is software that doesn't have a debugger. Because one of the things that turns out is humans love to introspect and develop and iterate on something. They love the tangible idea of working with software, and except for the software that they don't want to understand, the software that they never ever want to be able to understand what's going on, that we call configuration often. And so we go, the rest of the system I need to understand, but this can be a super annoying black box that makes me hate myself. But that definition doesn't have people in it either. There's also software that people don't believe is software, which is one of my favorite definitions of configuration management and configuration. So actually, a show of hands. How many of you think that configuration and software are the same thing? Ooh, this is Configuration Management Camp, and so I'm not surprised I got more than one hand. But, so I personally think they're the same thing. And I will convince you, because you're allowed to be wrong, it's okay, but software and configuration are the same thing. But this also doesn't have people in it. And if this definition doesn't have people in it, I mean, it has the word people, but people are not involved in this definition. So like, what is really the definition that makes sense here? This starts to get into this really cool edge of psychology. So let's take a step back. Let's try that one again. Configuration is how humans learn to adapt software to fit their needs. So this is one of the most fascinating aspects of how humans work. Humans are special in the animal kingdom for one reason, which is that they think they're special. But humans are special in the animal kingdom for other reasons. And one of them is that we have tools. Not a lot of other animals build tools, develop them, and iterate on them. Monkeys do, dolphins do, octopi do, a couple others do, birds do, humans do. But we happen to be really good at it. We happen to have made it our whole thing. We were like, super strength? Nah, screw that. I want a screwdriver. Okay, cool. We could have had super awesome stamina. We could have been useful. We could have had like healthier genetics, teeth that didn't break all the time, bodies that didn't fall apart in the first 20 years of life. But instead we're like, you know what? I really like keyboards. I'm gonna build these weird, like what kind of animal is weird enough to go, oh yes, we spent millions of years of evolution on these legs. I'm gonna just who does that? Really? That's what we decided to do with our evolution? That's what we decided to do with all our talent, is to sit there, not use any of the biology, and just like, weird. We are weird, and that is actually kind of cool. But so we use tools, and we use tools to understand the environment. We use tools to adapt to the environment and to make the environment fit for us, and to make us fit the environment. And it's this tool adaptation and use that gives humans the ability to build the language, to build the community, to shape the world in a way that fits for us. And with these tools, we built the world. We built our cities, we built our homes, we built things that give our families the food and safety and the shelter and the comfort that they need. And configuration specifically is actually a thing that humans do with tooling, which is, it's the process of taking this tool, taking the environment, taking your understanding of it, and tweaking everything together in this sort of soup in order to get it working for you. And that's what humans do. We do that. And we're really unique in our proficiency of doing it, even if we're not necessarily unique in the fact that we do it. But I love that. It's super, super cool. And so we, as people, are social beings. We need each other. We really, really do. We are wired to such an extent that one of the deepest, cruelest forms of torture for a human is to put them in a room all by themselves. That is legitimately one of the deepest, cruelest forms of torture for a human. It's just to deprive them of social norms, to deprive them of each other. We need it so deeply, it's baked into our brains. And with the collaboration of other people, we understand the world. Like, we actually do not learn correctly unless we are learning via collaboration. And there's research in psychology that shows this. And so one of the really, really cool things about this is actually a research-backed argument for why free and open source software works so well. Isn't that awesome? Humans need this collaboration in order to learn. Collaboration is the most effective method of learning, which means that the most effective method of software development is intrinsically something that fits the four freedoms. You need it. It actually is the thing that works. If it's open, if it's understandable, if it's modifiable, if you can share that modification back, if you can iterate on it with people and develop it with people and understand it with people, you are doing this socially driven development. And that is such an effective method of learning and collaboration that is basically the only one our brains are capable of doing. And every other sort of method of software development is figuring out how to get there, how to fake it, how to fake the collaboration learning, because we just sometimes don't admit to ourselves that it's the best way we do it. And that's actually pretty cool. That collaboration literally makes the world go round. Configuration then is learning. which, you know, software was also learning. And so I hate to break it to you, but that kind of means that configuration and software are the same thing. And so if you didn't agree with me before, I hope you agree with me now. That software, configuration, and learning are all different sides of the same coin. And they fundamentally have to be, because our brains just won't let it happen any other way. We're stubborn like that. So out of curiosity, let's play a game. If you're not quite sold on the configuration software thing, I'm going to give you sort of an example of something, and we're going to show of hands, is this incident, is this error in how we understand the system, was it caused by configuration, or by software, or by some other thing, or what? So the first one. In 2021, Facebook had a massive outage. This outage was particularly interesting because it showcased the hubris of a lot of designs of tech where you had mutually recursive things going on. So in this outage, everything was down, everything was broken, and the teams that could identify the problem was down, the team that could identify what the problem was, and the team that had the access to fix it were all 3 different teams in 3 different locations, and they could not message each other or communicate because the communication systems were down. So in order to solve the problem, they had to actually go through and dig in and contact each other outside of normal methods, and they needed an angle grinder to actually break into the server room because the server room's door keys were on the same network that was also down. And it was just this massive nonsense. They were down for ages, it was a whole thing that made international news. So this, was it configuration or was it code? So configuration, was this a configuration issue? All right. Was this a code issue? Okay, a lot of you remember this one. This one was a configuration issue. This one was the old BGP. They wrote a configuration file for BGP and they edited it, had a typo somewhere, misconfigured it, had a send all route that basically nulled all the traffic, that propagated, everything fell over. The thing is though, this could have been resolved in probably about 20 minutes if the teams were all working together, if the teams had access to each other, if they had physical keys on their doors instead of only digital ones. There's so many other things that could have made this a minor blip. So was it configuration? Or was it a whole bunch of other things too? Next one, Cloudflare. In 2019, had a really interesting outage where they had the web firewall. The firewall had this globally available super instant configuration update or rule update or engine update thing. And then they go, oh, we'll push an update. This update kicked everything over, and it turns out it was a backtracking regular expression, and this actually motivated Cloudflare in the future to switch the regular expression engine over into one that had constant time expression evaluation rather than exponential CPU usage. Because it turns out backtracking is bad. Which hopefully you knew that, but if you didn't, now you know. So was this configuration? Configuration? All right, what's this code? So according to their blog, they blamed it on the configuration as the main one because the configuration was where the regex was located. And they did a configuration change. And in the configuration change, the thing that was interesting was this particular type of change was considered a non-critical one. So it was able to bypass a whole bunch of checks. It went out globally, it did not gradually roll out. It missed a whole bunch of practices. They didn't have a way to roll it back. They didn't have a way to test it. They didn't actually test the CPU usage, but the main result that they had on there was actually configuration. But was it really configuration? I mean, it was also code. It's literally one of the solutions that they had was switching out the software that they were using for a different piece of software, which sounds like software to me. Like, I said the word software 3 times, it sounds like software, but it's also kind of configuration. So, last one, maybe. The Therac 25, how many of you remember this one? I see a whole lot of people that don't seem old enough to remember this. How many, just kidding. So the Therac 25, this one was a medical piece of software, and this happened around the years of 1982 to 1988. It was a computer-controlled radiation therapy machine, and this machine, previous iterations of this machine were human-operated. And then as they developed, they had a new version of the machine that was half human, half automatic. And this one, they were like, let's get rid of the humans entirely, let's make it fully automatic, fully managed, completely idiot-proof. And in fact, they made it so idiot-proof that occasionally it killed the idiot. 6 times. Actually, no, it only killed 3 people, but it damaged 6 people. And the documented incidents occurred when the high current voltage beam generated in the X-ray mode. It was delivered to the patients directly and gave them over 100 times the amount of radiation they were supposed to get. Which, as you know, radiation is bad. Except when it's not. But when it's that amount of radiation, it's always bad. Always bad. So this one, was it configuration? Or was it code? Or was it something else? Configuration? Okay, everybody's like, it predates configuration. All right, code? There you go, cool. So this one was interesting. Code, question mark. 2 main software faults were identified in the post-incident of this. An operator-triggered range condition allowed for setting the beam without the actual target being placed. So you could just aim the beam wherever you wanted to. A second fault allowed the beam to activate during the light mode, and so that's where the massive amount of over-radiation came from. So that, you could just accidentally aim the beam wherever you wanted to, full strain, all these other things. Here's the catch though. When they dug into the actual incident, a couple of things emerged. One was they had a single developer working on it who had never done this type of thing before. They had no tests, no practices, no anything else. They copied a bunch of code over, smashed into production, did no quality assurance whatsoever, and then that developer left the company and was never seen again. They literally could not find this developer during the lawsuit. This is wild. My headcanon is that the developer is one of the people that died and serves right. But the other thing was, so this developer had a lot of issues, but also the company thought that the software was perfect and had no defense. And because the software was perfect and had no defense, then obviously it must be the machine, it must be the hardware. But they touched the hardware and the hardware was fine, so therefore nothing could possibly be wrong. Which now we know software can occasionally have bugs in it. It's not often, only once every 12 seconds or so, but software tends to have bugs in it. And we understand that now. And what's this configuration? What's this code? What's this something else? So it also turns out that they removed almost every single physical failsafe that existed in the previous machines without really understanding whether or not those failsafes ever activated. So they removed a whole bunch of safety conditions that were actually just sort of part of normal operation. Like maybe something wasn't working right, a fuse blew in the previous generation, and then they would just go, oh, a fuse blew. But that was an incident that would have hurt somebody or over-radiated them. So sometimes what we think of as malfunction is just a quirk. Sometimes we think of as maybe a bug as sort of how things tend to happen. And it's our understanding of the system over time that really determines whether or not it was a bug or just something that needs to be fixed, or maybe sometimes it just happens. Once we dig through all these different types of incidents, isn't the answer kind of, isn't it always both? It depends. Yeah. So isn't it always both? Isn't it always that we have this really complex thing going on where people are learning from each other. People are learning with computers, with configuration, with software, with tooling. We're orchestrating not just the system itself, but more importantly, the relationships that we have with each other, the relationships that we have to the software. It's this orchestration, this understanding that actually gets everything working. The fact that the software turns on is just kind of a side bonus. And so if our relationship to understanding breaks down, it's not a surprise if the software also does. It also means that we can't really ever take a singular thing and turn it into, oh, it was this one root cause, or it was this other root cause, or here's a very, very easy solution to fix this forever. Which brings me into one of the hardest ways I learned this lesson. I had an outage that happened one time at a company that I used to work at. And this outage was so severe that it bricked and brought down the entire system, and it never came back up. Ever. So this was back towards the earlier half of my career. I was working at a company that was doing some medical software type of system, and nothing involving actual sensitive data, but it was in the medical health tech industry. And this software was running on a nice infrastructure stack that one person set up at one time. He was the only person that understood how it worked, which was fine. He still works there. Nothing could go wrong. It was running the Nomad, Hashy Stack, Vault, HashiCorp, all the things. Totally fine, totally normal. 3 controller nodes and a whole bunch of worker nodes. And one day, one very, very fateful day, the observability stack broke. But before I get to that part of the story, one of the aspects of this that made things really difficult was the company didn't care very much about its people. And so that made it very hard for the people to understand the system because there's no motivation for it. So as an example, one of the ways that the company showed that it didn't care about its people is that many people in the company, like the leaders, would brag about how they were taking advantage of other people in the company. And one person bragged about how they managed to hire someone for $80,000 US a year less than their market rate, just because this person didn't know their worth. And when I joined the company, I actually discovered and found out that the one black person on my team was being paid $80,000 US a year less than me. And the one non-binary person on the team was being paid $65,000 US less than me. And this pissed me off so much that I grabbed an encrypted anonymous spreadsheet, sent it to every engineer in the company, and got everybody to sort of utilize, put all their information data in there, and then use that to have very interesting conversations with their manager about their compensation. And that fixed the issue a little bit, but the pervasive problem of just not caring about the people was still there. As another example of that, this company had an incident management problem, which is that any non-200 response in a backend anywhere triggered a severity 1 incident. A single 404 or a single 500 severity 1 incident. 24/7, no filtering, no aggregation, no understanding, no metrics, no fun. And this was burning out all the engineers, obviously, and the engineers are complaining about it. The funniest part though, the most successful and the most rapid and the most accurate alerting response that we had was not the metrics that we had, it was the email system that we had that customers would use to email us when the system was down. This was actually about 4 days faster than the thing that was waking up everybody at 3 in the morning. Because that was not actionable, that was irrelevant, that had no bearing on the system health whatsoever. But when the customer emailed you and they said, oh, this is broken, you're like, okay, well, it's broken. And so I went to the leadership team and I said, we have two options. Because we're burning out all our engineers and this sucks, and this is annoying and this is terrible. Option one, we can actually spend the time required to fix the system, get it operational, get it manageable, make the configuration work, dial everything in, do that. But we're going to have to stop a lot of future work in order to do that because the time investment is too much. Or option two, because clearly our most superior form of alert management is email, we turn off the other one, the one that's waking people up at 3 in the morning. And the management picked that one. So I celebrated with the entire engineering team as we turned off all the alerting in the entire company. Which worked out splendidly. Foreshadowing. So the one fateful day, the observability stack, you know the one that I mentioned we no longer use? That one. But the observability stack broke on the Nomad cluster. And so the observability stack, for whatever reason, was only on the management nodes, only on the controller nodes. It wasn't on the worker nodes, it was only on the controller nodes. And it broke conveniently about a month after the one person who understood the system, the one person who had built it, the one person who knew it, had left. I mean, good for him. Like, the company was not doing great. The company it had already had a round of layoffs, it had already been struggling, it clearly didn't care about its people. Good on them for finding a better company, they cared about their people. But it meant that we had the system that was no longer working. We'd turn off the alerting, we'd turn off the error management, we'd turn off the observability, but now the observability stack was broken in a way that was breaking the rest of the cluster. And so I dug out the trusty, half-written, haphazard sort of documentation this person left behind. And I'm like, okay, so everything's falling over, the management nodes aren't working anymore, this is bad, what do we do? And the documentation had a section on node management. I'm like, perfect, that one. The documentation was actually for the worker nodes and not the management nodes, but I didn't know that. So it says, oh, to fix the nodes, what you need to do is you bring up a new node in the group, you wait for it to join the cluster and get it all happy and healthy, and then you bring down an old one, and then you cycle things in that way, newest to oldest, and then that'll rotate the entire set of nodes. So I said, brilliant, let's do that. So we added a node to the management set, and went from 3 nodes in the management cluster to 4. Some of you are catching this, What happens when you go from 3 to 4? You split brain the cluster, which means nothing has quorum anymore. And also wasn't really working in the first place. So nothing at quorum, it kind of wasn't working. And then we dropped the oldest node. So we lost a third of the state. We lost a third of the configuration, a third of the cluster health, a third of everything. Awesome. The node joined somehow. Everything seemed operational. The bare scant health checks that we had told me that nothing was completely on fire. So I'm like, okay, is the cluster better now? No. Wonder why. But no. So we're like, okay, we're going to have to do it again. Split brain the cluster again. Even more split and more brained. Brain down and destroy another third of the data, another third of the secrets that I would later learn were backed up nowhere. This is cathartic. Is the cluster working? Is the cluster functional? No? Okay. One more time. 4 nodes. It turns out you can't split brain something that's already like so far gone. It was so far gone. It wasn't even split brain, it was just split. It was just sad. And we brought down the last and final node, which deleted the last third of all the state, the last third of all the management, the last third of all the secrets that were not backed up anywhere. And the worker nodes were not responding to the new server that didn't know how to contact them for some reason. So finally, I reached out to the old guy, and I'm like, hey, what gives? And he said, well, so the worker nodes should be working because you cycled them, right? And I'm like, no, we did that for the management nodes because those are the ones that were broken. And he said 2 things that really hurt. The first one was, oh, that documentation wasn't for the management nodes. And secondly, the management nodes aren't really ever supposed to break.
Oh, I'm sorry.
They should have informed me. I'll just go over to the management nodes and tell them to get their shit together. Nope, didn't work. Okay, now what? And he said, well, can you restore from backup? And I'm like, no, we don't have backups. Because you didn't back anything up. And he said, well, we actually do have backups for the instances for the virtual machines, but they only last 15 minutes. And I said, you're telling me that I need to dig through an old forgotten console in AWS, find something within 15 minutes, know exactly where to look, pull that hard drive, and really? I was like, yeah. When did everything break? I'm like, yesterday. And he said, oh. And I said, yeah. Now what? And he said, okay, well, it's a good thing I don't work here anymore. But now, you're going to need to bootstrap it. And I'm like, cool. Does the bootstrapping code work? And he said, we'll find out. It did not. I had to bootstrap that thing, so for 10.5 days, I'm sitting there bootstrapping the shit out of this thing. Reverse engineering the broken documentation, finding out that the bootstrapping cluster had actually had all of its Terraform overridden by a second set of plans, and so you needed to do one set of Terraform plans, edit the Terraform first, reapply the first Terraform thing with the Terraform code, unedited it. Go to the second plan, apply that over onto the first set of nodes again, go to the third Terraform plan. You can see where I'm going with this. It's not very configuration or management. And this whole infrastructure as code thing is nonsense. This is infrastructure as pain. So the company has an offsite. And so day 10 into the outage, everything, like not even just down, everything's hard down. Everything's 100% down. Everything's 200% down. Except for the stuff on AWS, that was fine. So then we go to the offsite, and a couple of things happen all at once. The first is that everybody else has fun, and then me and the other 2 people on the reliability team do not have fun. Because we're sitting there, unfucking. The other thing that happens is AWS released serverless Aurora, which worked flawlessly for almost everybody, except us. We somehow got a silently corrupted database with all the health checks perfectly working, and no indication and no way to restore it or back it up. The data was there, but if you queried anything, you got an empty result. Fantastic. What did you use this database for? Nothing important, just all of the health data. All of the user records, all the logins, all the user account, everything. We only used it for everything, right? Like all the stuff that made money. No biggie, we'll just restore it. But in order to restore it from backup, you change to ARN. But because this database had been up for 4.5 years, that ARN was hard-coded into everything. And so I'm sitting there. And the third thing happened. which was, you remember how I said this company didn't really care about its people? Well, they laid all of them off because they're like, everything's working pretty well. We don't really need this, 80 engineer team anymore. They're not making us enough money, and we're just going to switch into do, patient, healthcare data stuff. We'll just leave the back end running forever. The one that's been down for 2 weeks, that one. We're just going to leave that running forever. That's fine. So 10 a.m. I delete the database and restore from backup. The cluster's not up yet, but that needed to happen first. Noon, half my team was gone. 1 p.m., I was gone. And so during the exit interview, I just informed them politely, nothing's there anymore. You're spending $15,000 a month on CI systems that no longer connects to anything. You're spending $6,000 a month on a database nobody can read. Nobody knows what it is because it's not connected to anything. And all of the clusters are broken. And it will take me another 2 weeks to fix everything, maybe. And if you want my consulting rate at a 0, I'm out. So what's this a configuration change? Well, what's this a software change? What caused this outage? Was it configuration? Was it software? Or was it something else? It was kind of just a whole clusterfuck of stuff, right? You can't narrow it down to just one thing. It was everything. It was everything. It was everything. Configuration and code and state and the passage of time, the mortality of humans. It's all the same side, different sides, same coin. It's all connected, it's all tied together. The software development is a radical act of vulnerable learning. And if you don't have an environment where you can be vulnerable, where you can learn, then software is not going to work. You're going to build this cool thing, and it's going to work perfectly right up until the day it doesn't, and then it's never going to work again. It's never going to get back to where it was. It's never going to do anything. You're just going to watch it go down in a pile of flames, and then you just have to kind of wave it goodbye. We also do this really interesting thing of we understand the new in terms of the old. We do this with software evolution, we do this with the configuration evolution, this whole concept of configuration management of eventual consistency, which is also kind of the same thing as eventual chaos, right? But this delta change, the previous to the next, the old human to the next human, you're not the same person you were yesterday. The system's not the same system that it was 5 minutes ago. Your understanding of the system is not the same as the understanding was 5 minutes ago. And it never will be. But that's okay. You're never going to understand things. Management's kind of a lie. The world might be burning down in flames, and everything you ever knew about or hoped or wondered or took for granted might disappear in a moment's notice underneath your feet. And you'll be able to do absolutely nothing about it. And it will take everything you have from you sometimes. But the people will always be there. And the people together are what make this whole spinning rock with a bunch of people moving around on it, making noises out of their mouth. It makes it all worthwhile. After all, it's about the people. Speaking of people, if you have a work visa and you want to hire me to not live in the United States, I have 2 minutes, I'm just going to stare at you. Just kidding. You have some announcements?
Any questions?
Cool. I explained everything perfect. Oh, one person over there.
What happened to the company?
The question was, what happened to the company?
So the company, finally 2 years later after limping around, did get acquired somehow. I don't know how they bribed the other company. But what happened was this company actually, everything fell over. They managed to take the original person, the one that actually knew how everything worked, and hired that person back on as a consultant. And that person spent about 5 hours a month, 5 to 10 hours a month, made the same salary they used to, and just unscrewed up everything for about a year, had it limp on somewhat successfully, and the 3 developer skeleton crew that they had sort of cobbled things together for about a year and a half, 2 years after, until the company managed to grind down into a halt just long enough to get acquired and then disappear into the ether. It does still exist, but not really. Cool, that's time. Thank you very much, everybody.